under a Earth observation degree? Should we look at radiometrics and magnetics that the geologists use? It's also Earth observation. So some thoughts on that. But we are in a university environment, so we have to teach all other kinds of modules. We can't just have Earth observation 1, Earth observation 2, Earth observation 3. So there are these other things that we have to teach, which lay the foundation. And that's what Plato also recommends, why we need all these different hours of these different categories. Mathematics, physics, statistics, these things you cannot work without as a scientist. Computer science, Lee Anomalai yesterday said a very wonderful quote where it says, we need to embrace the cross-pollination of computer scientists into traditional Earth observation domains. And I come from a somewhat geography, somewhat geology, a little bit computer science background as well. And from that side, I meet pure computer scientists who have moved into computer vision and classification. And it's amazing to see what computer scientists can do. That sounded a bit condescending. But it's like, wow, you guys. No, it's great. So we need computer scientists. And obviously then having subjects called the GIS, remote sensing, photogrammetry. Do we force people to take geography? Do we think that's an important thing? Do you need to understand spatial formats and the world around you in that way? And then how much application domain subjects do we put in? Geology, forestry, biology, even down to urban studies, sociology. It's all applications of Earth observation. So should we leave space in an undergraduate degree for people to study something that they find interesting, that they would like to apply remote sensing to? That's a question I'm putting out there. All right. Entry requirements and prerequisites. Just briefly, this is our university's entry requirements that Adrian mentioned now. You need 70% for mathematics if you want to study things like computer science. There's possible for you to come in with a 60%, but then there's certain things you can't study. You need 50% for physical sciences, 50% for your languages. So this is just the basics, and like Adrian said, it's good. It means we're getting prepared students in. But this is something, we, for example, students at our university can come and study geography without having geography at school, which is great. It means it opens up the field to a lot of people, but it means you basically have to start at scratch in your first year. So you don't build on any prior knowledge really. So that's also something to consider. And then the guidelines or restrictions, what should these programs adhere to? Or what would such a qualification have to mind? It would have to mind Plato and Saknas, yes. These bodies specify certain things. And then the university and the Department of Higher Education and Training and SAQA have certain regulations. Plato groups all of this stuff under its category of photogrammetry and remote sensing. A lot of stuff in there, let's leave that for now. The bottom line is, like Adrian showed, this is what Plato recommends or requires, which is 75 lectures. It's just more than one university course in photogrammetry and remote sensing. So this wouldn't be enough, in my view, to call something an Earth observation degree with just 1.5 modules or courses or something. If you break it up into a little graph with all the things that Plato wants, there's photogrammetry and remote sensing, 75 hours. But it does allow, like Adrian said, these selected core study areas. So 210 extra hours that if you want, you could fill just with photogrammetry and remote sensing. And then this unspecified discipline-specific electives where you can put in your forestry and your geology and whatever you want if you would want to. So those are the Plato guidelines. In terms of Saknas, yes, we saw that you do need a degree, a science degree, which is accredited by SAQA. So we do need a degree. Let's make it an Earth observation degree. All right. And then the university has its own guidelines. Lots of universities say, you're not allowed to call something a BSc degree unless you have a certain specific minimum of what they call core or sort of pure scientists, which is usually mathematics and physics and biology, and in some cases even computer science, which we like. So that's something you need to consider. And then obviously SAQA standards, your degree must be accredited. So let's just quickly go through the Stellenbosch example. This is our program, which we call Geoinformatics program. It's a BSc degree. It has the same admission requirements as the faculty of science, which means 50% for physical scientists and 60 or 70% for mathematics, depending on which route you want to take. There's, thank you. Like we said, we can't just pack it full of Earth observation modules. We're working within a framework, so we're limited in some way. This is our take of trying to do something which is strongly geospatial and technological, but also trying to please everybody at the same time. We would like to be Plato accredited. We would like to have a high level in the international view and be good for SACNASP. So there's lots of other things in here as well. There's computer skills. There's a thing called scientific computing skills. We have students be able to choose between a strongly computer science stream and a more informatics kind of stream, more databases and web-based applications, where they can also take biology, chemistry, and physics if they want. No, actually, they have to take mathematics and physics. They can choose some other streams, eventually ending up with majoring in a new subject we created called Geographic Information Technology. This goes on into an honors degree, where 25% of the time and the mark is advanced GIS, 25% is spatial modeling, 25% is an advanced Earth observation module, and 25% comes from their research project. Just to quickly give you an idea of what all our geographic information technology modules from first year to honors look like. The remote sensing modules there's Introduction to Earth Observation in the second year. For digital photogrammetry, there's Earth observation in the third year, and then a more advanced synthetic aperture radar and hyperspectral in the honors. But there's a lot of, the subject contains a lot of GIS and geographic information technology stuff. So there's Introduction to GIS, spatial data management, a new module on spatial data acquisition, which would be in situ measurements, field measurements, data warehousing, etc. Spatial analysis, spatial modeling. So a lot of this stuff supports our Earth observation training. But whether we call it an Earth observation degree on itself, we've got more than enough according to Plato to actually call it that. So I think